Welcome to chapter 2 of the series. The topic of the day is a prime and a composite number. What I expect you to know by now is what is a factor, what is a multiple, and maths table in general. In case you don't know these concepts or you need to revise those concepts, I'll link to the video down below. You can watch the video, do the exercise, and then come back to this to gain a better understanding of what is a prime number, what is a composite, what is a factor, what is a multiple. All of these terminologies I'm going to use in this video. So it's better if you have a firm understanding of what is a factor or what is a multiple. Uh, in case you're well aware of all of these concepts, let's get started. So what is a prime number? A prime number is any number that has only two factors. That's a prime number. Whereas a composite number is the one that can have more than two factors. So let's take an example of number 2. 2 can be written as 1 into 2 or 2 into 1. So only two factors. What about number 3? 3 can be written as 1 into 3 and 3 into 1. So only two factors. First factor is 1 and the second factor is the number itself. It has no other factor. That's a prime number. What about number 4? What do you think 4 is? Is it a composite number? Is it a prime number? I think it's a composite. What do you think? Okay, let's try this. 4 can be written as 1 into 4, that is equal to 4. 2 into 2, that can be equal to 4, that is equal to 4. And 4 into 1 is equal to 4. So it's a composite number. It has three factors, 1, 2, and 4, more than two factors. That's the criteria. What about number 5? 5 is a prime number. Same is the case with number 6. 6 has four factors, 1, 2, 3, and 6. That's a composite number. What about number 7? That's prime number. Number 8 is a composite. What about number 9? What do you think number 9 is? Do you think it's a prime number? I think it's a prime number. Don't you think? Okay, let's do the exercise. You can say 1 into 9 is equal to 9, 3 into 3 is equal to 9, and 9 into 1 is equal to 9. So it has more than two factors. It's not a prime number, it's a composite number. Remember this. 9 is a composite number. Don't ever say that it's a prime number. It has more than two factors. So all of these numbers 2, 3, 5, 7, and 11, they are prime numbers. And 4, 6, 8, 9, and 10, they are composites. You may have noticed that I started from the number 2. I didn't say anything about number 1. So what is it? Is 1 a prime number? Is it a composite number? Then again, look at the criteria. So for it to be a prime number, it needs to have two factors. 1 is only divisible by 1, so it has one factor. It doesn't have two factors, it doesn't have more than two factors, so it's neither a prime number nor a composite. It's none of these. So a prime or a composite number starts from number 2 and goes onwards. One rule that you need to remember is all the prime numbers are odd numbers. However, there is one exception, the number we discussed at the very start. That's number 2. But all the odd numbers are not prime numbers. The example of which is number 9. 9 is an odd number, but it's not a prime number. Let's take an example of John. John has 24 candies and he's thinking to himself, I need to divide those candies equally into different bags. How can I do that? He can put all of these 24 candies in bag 1. That's not division exactly, but that's bag 1. Or he can make 2 bags of 12 candies each. 3 bags of 8 each, 4 bags of 6 each, 6 bags of 4 each, 8 bags of 3 each, or 12 bags of 2 each. These are all the possible combinations that he can make to put all of these candies into different bags equally. Pretty simple. Now, we have Susan. Susan has 45 candies and she's thinking to herself the same thing. I need to divide those candies equally into different bags. Can you divide that yourself? That's an exercise for you. Go through the John example and do it yourself. Let's do the remaining exercise 1A. Previously, we are done question number 1 through 6, and there I recommended you to use your own mind, use your own skills to compute factors of different numbers. Now, for the question number 7, the book specifically asks you to use a calculator. It doesn't ask you to do it by your own mind, use your own skills. It specifically asks you to use a calculator. Why is that? Is because, well, it's a big number, and if you start finding out the factors of 480 by your own mind, it's going to take a lot of time and a lot of effort, which is not required at this stage. So you're gonna learn how to use a calculator to compute different factors of a given number. 480, we all know that 1 is a factor of all of these numbers. We don't need to do that manually on the calculator again. But from 2 onwards, I show you on the right side of the screen how to use the calculator, how to compute the factors, how to find out the factor by hit and trial method, divide 480 by 2, by 3, by 4, by 5, all the way up to 20. You need to go all the way up to 480 to find all the factors. Do it yourself. I'm going to do it for the first 20 numbers just to give you an idea, and then you have to do the exercise yourself. So 1 is a factor. We'll write it down, and then we're going to compute 480 divided by 2 on the right side of the screen. 480 divided by 2, that's 240. So it's completely divisible by 2. 2 is a factor of 480. I'm going to write that down on the left hand side, and then I'm going to do 480 by 3. So 480 divided by 3, that's 160. Again, 480 is completely divisible by number 3, so 3 is a factor of 480. Same is the case with number 4, number 5, number 6. How about number 7? Is 7 a factor of 480? Let's find out. No, it's not a factor of 780. There is a remainder. It's not completely divisible, so 7 can't be written as a factor of 480. On the left hand side of the screen, I won't write 7 as a factor of 480. What about number 8? 8 is a factor. Number 9. 9 is not a factor. Number 10. 10 is a factor. 11 is not a factor. 12 is a factor. 13 is not a factor. 14 is not a factor. 15 is a factor. I'm going to write that down on the left hand side. 16 is a factor. 17 is not a factor. We can't write that down on the left side. 18 is not a factor of 480 as well. 19 is not a factor. And the last one I'm gonna do is 20. So 480 divided by 20 is 24. 20 is another factor of 480. Now, it doesn't stop here. 20 is not the last factor of 480. You need to go through all the numbers from 21 to 480, do it yourself, do it on the calculator, and find out all the factors of 480 yourself. Component B, same way, you have to find the factors of 600, the factors of 960, and the factors of 936. It's gonna take you some time to do it even on the calculator. So take the time, do the exercise, and move on to the question number 8. Question number 8 is a word problem, and I have already given you how to solve this question using an exercise, using an example of John. But over there, John had 24 candies. Here, John had 48 candies, and he needs to divide them equally into different bags. Use the same formula, use the same technique, and divide 48 into different bags equally. Same is the case with Susan. Susan has again 45 candies. I hope you have done the exercise previously, the example previously. Do the exercise of 45 candies and divide 45 of them into different bags equally. Then comes Peter. Peter has a different suggestion. Peter comes to both John and Susan and he tells them that you need to combine the two of your candies. You have John had 48, Susan has 45. You need to combine all of these and you need to distribute them equally into different bags. So that's a tough one, right? Okay, do the exercise. Take time and then let me know if you have any difficulties. I'll solve the question as well. I'll post another video for that. But it's better if you do it yourself. So it's quite fun. Otherwise, word problems are quite hectic. All right, question number 9. Determine whether each of the following is a prime or a composite number. So it's pretty simple. We have done that before. Component A is 2. Now, is 2 a prime number or a composite number? Do that manually again. 1 into 2 is equal to 2 and 2 into 1 is equal to 2. So it has only two factors, 1 and itself, it's a prime number. Same criteria. Other example, 15. Can you make factors of 15? Start by making factors. First of all, that's the first thing that you do. Make factors of any given number. That's 1 into 15, 3 into 5, 5 into 3, and 15 into 1. Again, what was the criteria? Yes, more than two factors. It's a composite number. Same is the case with question number 9, part C, that is 17, 21, 27, and 29. You have to make the factors individually and then you have to determine, is that a prime number, is that a composite number? Remember the formula, remember the rule. That is, if it has only two factors, 1 in itself, then it's a prime number, otherwise it's a composite number. Revise that again and then start solving this exercise. Question number 10. Next 5 prime numbers after 30. Okay, for this you have to use the hit and trial method. At this stage, you can't be expected to know the next 5 prime numbers just by heart. You have to make factors of each and every number by yourself. So you'll take the example of, let's say you have number 31 and then you're gonna start making factors for 31. If it has two factors, it's a prime number. If it doesn't, then it doesn't fit the criteria of a prime number and it doesn't go here. The same goes for number 32, 33, 34, 35, 36, all the way up to 50. Even if you have to go as high as 60, 70, or 80 to find the next 5 prime numbers after 30, you do that individually. I think you have done the exercise by now. In case you pause the video, I'm gonna just write down the answers to that. That is 31, 37, 41, 43, and 47. These are the next 5 prime numbers after 30. Next question. The last question of the exercise, that is, find 2 prime numbers whose sum is an odd number. Okay. Okay, I'm gonna give you a rule here again, that when you add 2 even numbers, the answer is an even number. If you add 2 odd numbers, then the answer is an even number. But when you add an even and an odd number, the resultant answer is an odd number. Remember, the only exception that I gave you, that all the prime numbers are odd numbers except for one. Which number was that? That was 2. So only 2 is the even number, that is the prime number. All the other even numbers are easily divisible by 2, by themselves, by 1, so it has more than 2 factors. They are composites. Only 2 is the number that is an even number and prime number at the same time. So you can add 2 and 3. The resultant answer uh, is an odd number. Both of these are prime numbers. What about 2 and 5? Again, the answer is 7. That's an odd number. Both of these are prime numbers. You can add 2 and 7. The answer is 9. Again, it's an odd number. Resultant answer is an odd number, and the two numbers that we added are prime numbers. What about 2 and 9? Is 9 a prime number? Does anyone remember that? No, 9 is not a prime number. The next prime number is 11. So 2 plus 11 is equal to 13. That's the end of the exercise. Do the exercise, take your time, and I'm going to see you in the next video. Thank you so much for your time.